Okay, Unit 7, Day 6. We're going to talk about why canceling is so dangerous and how to compose inverse functions with trig functions. Now, you would think that squaring and square rooting undo each other. Well, you're right and you're wrong. If I take 3 and I square it, I get 9. And then if I square root it, I get 3. So yes, I start with 3 and I end with 3. But if I take negative 3 and square it, I get 9. And the square root function of 9 only gives me 3. The square root function gives me one answer. And this time I start with negative 3 and ended up with 3. They did not undo each other. So f of x is x squared. G of x is the square root of whatever you give me. And true, I get x if x is positive, but you saw just a moment ago, if x is negative, it doesn't work. To fix it, I can say that I get back the absolute value of x. That way both the positive 3 and negative 3 work when I take the composition of squaring and square rooting. So no, not for all x if x is negative. So if I want to take the square root of x squared and get my answer back, my x better be positive, or 0 also works. The same thing is true here, except you can say, well, if I'm going to take the square root first, it better not be negative to begin with before I square it. But again, I better just say that x is greater than or equal to 0, positive or 0. The same is true for trig functions. Now, inverse sine. We talked about that inverse sine will only give you angles between pi over 2 and negative pi over 2. And sine values only give us values between negative 1 and 1. Remember the domain, or the range of sine amplitude goes up 1, down 1. The same is true for inverse cosine. Inverse cosine only gives us angles between 0 and pi. And again, cosine gives us values between negative 1 and 1. Inverse tangent, like inverse sine, only gives me angles between negative pi over 2 and pi over 2, but the tangent value will still give me values between negative infinity and infinity. So let's work from the inside out. Here is pi over 4. Sine of that is sum y over r. We really don't care about that. We want to go back to what's the angle that gave us that sine value of y over r, and pi over 4 is the same. And so you go, oh good, look, they cancel. Okay, let's look over here. Negative pi over 6 is here. Sine of that is again sum y over r, but ultimately we want the angle that has that y over r, and again we're back to negative pi over 6. So again you could say, oh, they cancel, but here's where you're in trouble. 5 pi over 4 is here. Sine of that is sum y over r, but I can't go into the third quadrant for inverse sine. Inverse sine has to be between negative pi over 2 and pi over 2. Well, if I take negative pi over 4 over here, it has the same y, negative, and the same r. Since that's the only angle I'm allowed to use, now we can't cancel. We have to think. Notice this time we want the sine value at the end. So when is sine negative, it's in the fourth quadrant, because inverse sine, I can only be between first quadrant and fourth quadrant. So here's my negative root 3 over 2. And here's our angle. But ultimately, we don't care about the angle. We just want the sine. And isn't the sine the value they gave us earlier? So in this case, you could cancel and be a lot more confident. Here's again the dangerous situation. 310 degrees is into the fourth quadrant, which makes a reference angle of 50 here, 360. Sine of that is some y over r, but I want the angle that has that y over r, but because I can only go into the fourth quadrant negatively, I need to do the negative 50 as the angle that gets into the fourth quadrant, not the 310. Now we're looking for an angle that is a sine value of 3. Well, let's see. Positive first quadrant, sine is opposite over hypotenuse. How in the world are you supposed to get a hypotenuse smaller than one leg of the right triangle? That's ridiculous. Undefined.